Let's try a tricky volume question. A cylinder that has a diameter of 80 centimeters, so here the cylinder has a diameter of 80 centimeters, is partially filled with water. There's the water. A ball with a diameter of 10 centimeters, here it is dropped into the water, and it is completely submerged. It's underneath the water. How much does the water level go up by? So the key here is to recognize that when you put things in the water level rises. Imagine jumping into a bathtub. The water level rises. Now the question is how much? How much does this water level rise? So let me just sketch a picture here and perhaps you'll see exactly what's going on. So the key idea here is that this water level will rise as much as the volume of the ball is. So the bigger the volume of the ball is, the more it will rise. So what we have here is an imaginary cylinder. So this here is a cylinder, and it will rise by a little bit. So here, what we have is we have the volume of this hollow cylinder, this one here, is equals to the volume of the submerged ball. Exactly. So meditate on this line here. Whatever you put into the water, that's going to make this volume the same. So the volume of the cylinder and the volume of the cylinder formula is going to be the pi r squared, that's the area of the top, times the height, is equals to the volume of this ball. So you should access your volume formula for a sphere. It's 4/3 pi r cubed. Now the tricky part here is we're dealing with different radiuses. This is the radius of the cylinder, whereas this radius is the radius of the ball. Please don't confuse these different r variables. So we have pi r squared h, and that's what we're trying to solve. We're trying to solve for h. This here is variable h. So this radius of the cylinder is going to be half of 80, which is 40. So the common mistake is to just plug in 80, but it's actually half of that. The radius here is going to be from the center to here. This is the radius of this cylinder, is equals to 4/3 pi r cubed, and the r here is the radius of this ball, which happens to be 5. So the rest is just algebra. So what we have here is 1600 pi h is equals to 500/3 pi. And so divide both sides by 1600 pi. We get h is equals to 500 pi/3, all divided by 1600 pi, which, by the way, is the same thing as 500 pi/3 times 1/1600 pi. So we can continue simplifying using our crossing out here. You can cross out the pi here. You can also cross out, divide diagonally here by 100, so we end up losing these two zeros, and so we can multiply across now. 5 times 1 is equals to 5, and 3 times 16 is equals to 48. And so this here is your exact answer. Alternatively, you could have used your calculator to calculate this as a decimal, and the answer we get is approximately 0.10 4. We're talking about centimeters. So what makes this question a bit tricky is the idea of using some algebra, dividing and just refreshing your fraction simplifications, and you have to be comfortable with your calculator to deal with this many different numbers. And also, conceptually, you need to memorize and understand that whatever you put in makes the water rise, and this hollow imaginary cylinder here is going to have an equivalent volume. So whatever you put in and what you get, whatever this shape is, they're going to have equal volumes. Now, it doesn't have to be a sphere. It can be any object. Whatever you put in, that total volume is going to be equivalent to whatever you're going to create here, this raised volume here.